Alright, in this video we will be learning about percent composition. Percent composition basically tells us how much of a compound is each element in the compound as looking by mass. Percent composition is oftentimes measured as a way to determine the formula of a compound. The equation that we use for finding percent composition is given here at the top. You take the molecular weight of an element of interest divided by the molecular weight of the entire compound, and then you multiply it by 100% to put it to give it those percentage units. So we want to know, for example, what is the percent composition of each element in water. First, we need to make sure that we know what is the formula for water. So water is H2O. And if we want to know what percentage of water is hydrogen by mass, the percent hydrogen would equal molecular weight of the element of interest. Now, molecular weight of hydrogen is 1.01, so we put that on top. Now, but there are 2 hydrogens in the water, so we multiply that by 2. Then on the bottom, we put the weight of everything in the compound, so it's the hydrogens and the oxygen, and then again we multiply this by 100%, so we will get the percentage of hydrogen. If we wanted to find the percent of oxygen, it would be 16 on the top. When we're done, because there's only 2 elements in the compound, we should find that they add to 100%. Okay? If I want to do the same thing for ammonia, if I want to do something similar for ammonia, let's say if I want to know what is the percentage of nitrogen in ammonia, ammonia is NH3. So if I want to know what is the percent N for nitrogen, if I look up on the periodic table, is 14.01 grams per mole. And so on the bottom, I'd add 14.01 from the nitrogen plus 3 times 1.01 for the hydrogens. And then times 100% would give me the percent composition of nitrogen in ammonia. So percentage composition can be measured in various different ways in lab. Oftentimes it involves one of 2 reactions, either taking a chemical and decomposing it, say by heating it up, so it breaks into its constituent parts at a high enough temperature, and then if you can measure how much of each substance comes off, and that can be done by various different methods. Or what we'll be doing in lab is taking and forming a chemical through a direct combination reaction, and you can then figure out how much of each element went into that direct combination reaction, so you can figure out by that what portion of the entire mass is each element. When you have the percent composition, you can use this to find what's called the empirical formula. So the empirical formula gives you just the ratios of atoms in the compound. It doesn't give you the actual numbers. When we talk about the formula for an ionic compound like table salt NaCl, that is by definition just an empirical formula. It just tells us for every 1 sodium in the element, we have 1 chlorine atom. Okay, it's just that's the ratio. It doesn't say that those 2 things are bonded together in any particular way. Okay, so if I want to get the empirical formula for an atom, I use these steps given here, these 3 steps, and we'll work together an example problem. The problem will work. We'll do the one that is the compound that contains 80% carbon and 20% hydrogen. So if I start off and I have something that's 80% carbon and 20% hydrogen by mass, and I want to know what empirical formula could make this work, I could certainly guess and check, but I can figure out. So I start with the fact that if it's 80% carbon, I treat it like I have 80 grams of carbon, and I find out how many moles of carbon that is by multiplying by 1 mole for every 12.01 grams. And for hydrogen, I say I have 20 grams of hydrogen, because if I have 100 grams total of the compound, it would make 20 grams of hydrogen, and multiply that by 1 mole for 1.01 grams, because here I'm working with carbon, here I'm working with hydrogen. So hydrogen is 1.01 grams per mole. So I take 80 and divide by 12.01. and I get that this is 6.66 moles, and I take 20 and divide by 1.01, and I find this is 19.8 moles. The whole point of an empirical formula is look at what is the ratio of one to the other. Okay, so I look at, well, what is the ratio of 6.66 to 19.8? And so to simplify that, I'm going to divide all of them through by the smallest number. Okay, so I take 6.66 divided by 6.66 and get out your calculators. That's 1. I take 19.8 divided by 6.66. I'm going to find that that is a number very close to 3, so it rounds to 3. This means my empirical formula is C1H3, or more simply, you can just write CH3. Now, the actual molecule that comes from might not be CH3. It could be C2H6, or C3H9, or C4H12. Now, I'll find, if you knew more about chemistry, you'd find, well, there's not very likely you're going to have a C4H12, that this is most likely C2H6. But again, empirical formulas only tell you what's the ratio, that I find carbon and hydrogen in the molecule in a ratio of 1 to 3. Oh, like I said, I already split that out. Okay, molecular formula. For molecular formula, now we're actually looking at what are the numbers of each one. In addition to knowing what the percent by mass of each element in the compound is, you'd have to know what the molar mass of the compound would be as well. And you can get the molar mass of the compound by such experiments as a titration, which we will do later on in school. If you had fancier equipment, you could get the formula mass using a mass spectrometer or something else. See, somehow you have to have the molar mass of the compound. So the first step in finding the molecular formula is you find the empirical formula, and then you do these other two steps after that to get what the molar mass is. So we're going to go on, we're going to find what the molecular formula for a compound that has 150 grams per mole, and it's 40% carbon, 6.67% hydrogen, and 53.3% oxygen by mass. So we want to know what is that compound's molecular formula. And again, we could guess and check. We could try all sorts of different combinations of carbon, hydrogen, and oxygen, try to get them to add up to 150 grams, check to see if that's 40% carbon by mass, 6.67%, and so on and so on. That would take forever, unless you're just lucky and you happen to get it right away. So I start off with the fact, again, I want to do the empirical formula first. So I start off with carbon. If it's 40% by mass, I pretend like I have 40 grams of it, and take it times 1 mole per 12.01 grams. So I have 3.3 moles of carbon. For hydrogen, I have 6.67%. Multiply that by 1 mole per 1.01 grams. And so I have 6.6 moles of hydrogen. For oxygen, I have 53.3%, so 53.3 grams times 1 mole per 16.00 grams. And I find that I have about 3.3 moles of oxygen. Now to get the ratios of carbon, hydrogen, and oxygen, I divide them all through by the smallest. So 3.3 moles was the smallest. And I find the ratio of carbon, hydrogen, and oxygen would be 3.3 divided by 3.3 is 1, 6.6 divided by 3.3 is 2, and 3.3 divided by 3.3 is 1. So my empirical formula is CH2O. But that is not my molecular formula. To get my molecular formula, I got to find, well, what combination of CH2O, what has that ratio, but also has a molar mass of 150 grams per mole. So what I do is I find out, well, what's my empirical formula mass? So I add up 1 carbon, 12.01, plus 2 hydrogens, 1.01, plus 1 oxygen, 16, okay? And I'm going to get 28 plus 2, so that's 30.03 grams per mole. Well, my entire compound has a mass of 150 grams per mole. So I take 150 grams per mole, and I divide that by 30 grams per mole, and I find that it gives me 5. So there are 5 of the empirical formulas in my molecular formula. So instead of CH2O, my molecular formula must be C5H10O5. Okay, so that would be the molecule that has the formula of a molecule that would be 40% carbon, 6.6% hydrogen, and 53.3% oxygen. All right, since there's time, we're going to work through just one more. What if I have a compound that is made up of, in lab I found that it was made up of 4.9 grams of nitrogen and 11.2 grams of oxygen. It has a molar mass of 92.0 grams per mole. So I would take, again, start off with the bag. I got 4.9 grams of nitrogen. This one's not done as percent, so we just take the grams as it is and go by 1 mole per 14.01 grams of nitrogen. So take 4.9 and divide by 14.01. So I have 0.0 or 0.35. I guess I have 3 significant digits. 0.350 gram, or sorry, not grams, moles of nitrogen. For oxygen, I start off with 11.2 grams. Take that times 1 mole per 16.0 grams. .700 moles of oxygen. Divide it through by the smallest. So I find for nitrogen 1, oxygen is 2. So my empirical formula would be NO2. And if I want to know, well, what would my molecular formula be then, I find the empirical formula would have a mass of 14.01 plus 2 times 16. And 2 times 16 is 32 plus 14 would be 46 grams per mole. So if I take that 92 grams per mole and divide by 46 grams per mole, I find that equals 2. So my molecular formula must be twice my empirical formula, so it would be N2O4. All right, hopefully that gives you enough to get started on it. You'll be working on a practice worksheet next time we have class.